Hi guys, this is Mohammad P, a tutor on Chegg.com. Today we are talking about continuity and discontinuity of a function. So the general definition that we use to check if a function is continuous or not is that the limit of f of x as x approaches to a from the left side must be equal to the limit of f of x approaches to the right side approaches to a from the right side and must be the same as f of a, which is the exact value of the function at a, and these must be equal to a real number. So basically, if the left or right side limit is infinity, so that's then definitely it's not going to be continuous. So the first two part here is telling me that the function of f of x has to have a limit, basically. So the limit of f of x as x goes to a must exist. That's actually the main condition to be continuous. If the limit does not exist, you can say, okay, this function is discontinuous at that point. Okay, graphically, if we want to look at the graph and see what's going on when it's continuous or not, when you have something like this, for example, this is point A, as the function approaches to the A from the left and right, obviously it has a limit, let's say that's L, and also exactly at x equal A, you see it's defined at y equal L. So the left limit and the right limit and the exact value of the function, they're all the same and they're all L, and L is a real number. So the examples of discontinuous situations is something like this. You have a jump. This function has a jump from the left side is approaching to, let's say, L1, and from the right side is approaching to L2. And here is basically x equal a. And as you see, this function is defined at L2. So the right limit and the value of the function, so basically this part and this part are equal, but they are not equal to the left limit, which is L1. So I can say limit of f of x as x goes to L1, x goes to a from the left side is L1, and the limit of f of x as x goes to a from the right side, that's L2. Also, f of a is equal L2. So these two are equal, but they're not equal to the left limit. So that's one of the situations that we say we have a discontinuity. However, this function is basically continuous from the right side because the right limit and the value of the function is equal to each other. Okay, so now we are going to do an example here. Let's say f of x equal 3x plus 5, and the other, so this is for x less than or equal to 0, and then the other part is going to be negative 2x plus 5, x bigger or equal than 0. So when you have a piecewise function and they ask you to see if this function is continuous or discontinuous, the main point that you have to check is the point that the function is changing. For less than 0, I have this function, and for x bigger than 0, I have this one. So the function by itself is changing for the values less than 0 and values bigger than 0. So I need to check the continuity at x equals 0. So in order to do that, I'm going to take the limit of f of x as x approaches to 0 from the left side, which is limit of 3x plus 5 as x approaches to 0 from the left. That's 3 times 0 plus 5, that's going to be 5. And the limit of f of x as x approaches to 0 from the right side, That's a limit of negative 2x plus 5, x goes to 0 positive. It's going to be negative 2 times 0 plus 5 equal 5. By the way, I need to remove this equal sign because it's either defined for the top one or the bottom one. It shouldn't have the equal sign for both. Okay, so as we see, the left and right limits are equal. So the first condition here is satisfied. So left and right limits are the same, so the function has a limit, and that's equal to 5. Now, the last thing that we need to check is the value of the function at that specific x value. So we are checking x equals 0, so I need to find f of 0. As you see, because we have equal sign here, the 0 is defined for the top one, so I need to plug in the 0 into that. So 3 times 0 plus 5. So f of 0 is also 5. So left limit is 5, right limit is 5, and the value of the function is 5. So they're all equal. So that was the only point we were worried about it. So the only thing that we need to check, that's x equals 0, and it's okay, and we don't have any issue with that. That's totally continuous. Also because these two functions here, they're polynomials, so they're also continuous on the other points, and we don't really need to check that. So we can say f of x is totally continuous, and that basically allows us to write f of x is continuous on all real numbers. So I think that's it. Just remember the main definition that we use to check a continuity at the point. The left and right limit and the value of the function at that point has to be all real number and all equal to each other. I hope that you all enjoyed, and until the next video, I wish you the best and have a wonderful day. Goodbye.